Hello friends, myself Munish Kumar from Khandelwal College Bareilly. Today we discuss on modulation. Now first we know what is the need of modulation. If we transmit a information signal directly, then we require a long antenna, or second, the information signal may be mixed with the other signal, and which create the difficulty at the receiving end to separate from one to another. Now, what is the modulation? Modulation is the process by which some characteristics of high frequency wave, that is called carrier wave, is varied in accordance with the instantaneous value of modulating signal. If the carrier voltage or carrier wave equation is expressed by this equation, then the modulation may be divided in three ways. First, amplitude modulation, second, frequency modulation, third, phase modulation. That is, in amplitude modulation, the information signal changes the amplitude of the carrier wave without changing its frequency or phase. Whereas in frequency modulation, the information signal changes the frequency of carrier wave without changing the amplitude or phase. Whereas in phase modulation, the information signal changes the phase of the carrier wave without changing the amplitude and frequency of the wave. Now the amplitude modulation. We discuss on amplitude modulation. The carrier signal is modulated only in amplitude. The modulating signal is the envelope of the carrier as seen here. The required bandwidth is 2V, where V is the bandwidth of the modulating signal. Since both sides of the carrier frequency Fc, the spectrum is identical, then we can discard one half, thus the requiring a smaller bandwidth for the transmission. As we see from this figure, from both sides of the carrier, the similar information is available, so we need a half bandwidth of for the transmission. These are the figure of modulating signal. This is the carrier frequency signal, and this is the modulating signal, that is after the amplitude modulations. Now, degree of modulation or depth of modulation in amplitude modulation. The depth of modulation in amplitude modulation is the degree by which the signal modulated the carrier in the modulator at the transmitter and is quantified as m is equal to amplitude of modulating signal upon amplitude of carrier. And this is the carrier voltage and this is the modulating voltage, and this waveform is the modulated wave. And also from this figure we describe the modulating index, that is EC maximum minus EC is equal to MA, modulating index into EC. Similarly, from other, EC minus EC minimum is equal to MEC. From these equation we get MA is equal to EC maximum minus EC minimum upon EC maximum plus EC minimum. So this is the expression for modulating index. The total bandwidth required for amplitude modulation can be determined from the bandwidth of the audio signal, that is 2E. Frequency modulation. Frequency modulation. Modulating signal changes the frequency of the carrier signal. The bandwidth for the frequency modulation is high and it is approximate 10 times the signal frequency. The total bandwidth required for FM, that is the frequency modulation, is equal to 2 times 1 plus beta into V, which is usually 4 times. and this is the frequency spectrum of the frequency modulation. The phase modulation signal only changes in the phase modulation signal only changes the phase of the carrier signal. The phase changes the phase change um, it's the phase change in this modulation process. The frequency change, what the instantaneous frequency change is proportional to the derivative of the amplitude. The bandwidth is higher than for AM. The bandwidth in this process is 2 times beta into V. Thanks.